and thank you all for coming. So we're being recorded now. Linda's going to throw up some slides, and we're going to talk, and we're going to make some more progress and things like that. So it should be a good evening. And I guess I have to start, 10 minutes beforehand trying to get into here from now on. So, and let's see. I'm thinking of buying myself a green screen so I can have an attractive scenic thing behind me instead of my messy bedroom. But how are we doing there, Linda? We getting close?
Yep, just got it.
All right, excellent. Okay, here we go. First of all, it says terms of reference commentary, so I'm going to say some things. I'll see if Linda wants to say any things. We might do some polls. We'll do at least one poll, Linda, to see how people are doing. And then we'll have some Q&A. There's always Q&A. We're going to do some more normal distributions. And we're going to talk about testing to see if a sample comes from a normal distribution. That's our last low stakes assessment on statistics. And we might get into talking about confidence intervals here. I did give you some videos to watch about confidence intervals. So we'll see how far you go or how far we get. Okay, Linda, I'm going to ask you to advance the slide, and then I'm going to come back. Okay, I'm going to use this as some of my remarks, although I'm going to say some things that aren't here, but I'm just going to be re-emphasizing some things because I think this is important for you to have in mind. The biggest macro goal is teaching, learning, and progress continues unabated. And so my biggest thing is I want to provide the best content possible for you, the right course and things like that. That's my number one goal. That's what I'm working hardest at. And that's what I think I can do the best at. Number two, I'm trying to keep student anxiety in check. These are challenging times for everybody. I get it. And we'll work to accommodate, your needs and things like that. But I can't guarantee that there won't be anxious moments. Just like as a pilot, I could not guarantee that we won't have to fly through some turbulence. But that is my number two goal, okay? I know I can do number one. I think I'm pretty good at number two. Now, number three, I have to award you grades, and so I have to give you assessments. And you guys want grades, and you want credit for this. So that's, kind of our shared objective there. I know that this is a challenging time, and so beyond a wholesome discipline, I think this process will be as great, as gentle as it can be. And so I'm not looking to say, oh, I want to flunk everybody and stuff like that. That's not at all what I'm doing. Okay, and we are coming up on an important higher stakes assessment, though, and we've been practicing on that, and that's one of the reasons we do the low stakes assessment. So anyway, I'm going to go back to something that's not on the slide, but it's something I said in the very first video I made and shared with this class. If you focus on learning the material and staying engaged, the grades will take care of themselves, and people will be fine. Okay, Linda, that's all I kind of want to say. Why don't you go back to the earlier slide, and is there anything you want to say about, I don't know, assessments or posting or anything you want to say? I don't really care. Go ahead.
Not especially. The next low stakes assessment to submit it should be available later tonight. Honestly, if you're worried about the midterm, then just come talk to me, come talk to Professor Bradley. I promise it's not going to be as bad as you think it is. That's okay. Really all thoughts I have.
All right, very good. Now let's do a poll, and then I'll throw it open for any Q&A that any of the folk out here have. But Linda, let's do one of those polls and just how are you doing? And great, okay, and whatever you do. Yeah, Linda has these words, so that is good. And again, on these polls, it's fine to to play. Nobody knows who's responding how, and I'm just really seeing what's going on. So don't be shy about responding. Okay, Linda, let's do another poll and let's find out how many are here from NET and VCM.
Okay, one second.
Okay, here, no one was struggling who showed up tonight, which is good. You're okay. And I got to tell you, okay ain't bad these days. So, good for you. Okay. We're keeping inviting these net guys, aren't we, Linda?
Yeah.
Okay. And maybe they're just watching the videos that Linda is loading up, and that can be fine. I'm pretty much sure that most of the people are VCM people, and that's fine. Okay. Very good. And let's see. So we have tonight, and we have next class period. We'll be covering content. We might cover a little bit content in that last class meeting before the midterm itself, but that'll be a lot of that will be just making sure understand the collateral, making sure you understand the process, and all of that kind of business. So, and more of that will be being shared with the. In fact, your proctor for the VCM session did contact me, and actually I know who she is, and she's a delightful woman. And she said, can you call me this afternoon? And I was chock busy and I didn't get a chance to call her. But that's something I'm looking forward to because she's a nice person to meet with. Okay, that's enough. We're throwing it open now for any opening Q&As. You can always ask questions during the lecture itself, but let's just see if there are questions out there. Okay, Linda, I'm thinking that's no questions. And again, that doesn't mean you can't ask a question. That just means that we're not going to wait any longer here. Okay, so we'll ask questions, and that'll be fine. Okay, Linda, let's go advance the slide then, please. And you advance my comments there. Go to the next one. Okay, now I think, Linda, we did this entire problem. Yes?
I believe we only did part A.
Really? Okay.
Yeah.
All right, that's okay. So what we're going to do is we're going to talk about through D here on this, okay? Because I do want you to know how to do this, and we'll go to the other things. Okay, and Linda, somewhere in these slides are more normal distribution tables and things like that. So what we're going to do is I'm just going to add, so you think we did part A though?
Yeah.
All right, part A, and actually I think if we do A, B, and C, we've done enough with this. Okay.
Okay.
Because the rest of them are kind of similar to that. Okay. So that is good. So we're going to do, and Linda, so what we're going to do is we're going to change, but it's less than 250 days, and Linda has memorized those means and standard deviations. So Linda, if you can go to a chalkboard.
Okay.
I know it's a whiteboard, and draw a couple of bell-shaped curves. The one on the left will be called X space, and the one on the right will be called Z space. And Z, we know that's X space, and Z space is always normal 0, 1. She'll note that somewhere. Okay, so that's the mean, and that's the standard deviation there. And that's excellent. So we got that. And then in between, we have Z equal X minus mu.
Okay.
All over sigma. Wonderful. Okay, now that's what we need to do this, and I think the number on that was 2, what was it?
So it's what proportion of pregnancies last less than 250 days?
Okay, just if you're comfortable running with this, which I think you are, give it a go, and we'll make sure people feel good about this. Go ahead.
Sure. So we're talking less than 250. So if I kind of draw a picture in my X space of what's happening, then my mean here in the middle is 266. And then I'm trying to figure out what proportion is less than 250. So I already know that 250 is going to be on the left-hand side of 266. And because we're talking about the proportion that's less than that, then we're talking about the area under the curve shaded to the left of that line. So in z-space, then I need to figure out what my z-score is for 250. So all I'm doing is plugging that in for x. So that would be 250 minus 266 divided by 16, and that gives me -1. So in my z-space drawing, then I still have a mean at 0, and then I'm trying to find the area to the left of -1.
And Linda, I'm not really sure what slide that is. And I think by the way, you students do have access to these slides. So maybe Linda can, get at that some way. But she's not going to be switching back and forth between this because I think that would be hard, I think, Linda, right? So
yeah, it would erase everything every time I switch back.
Let's don't do that then.
So I'm looking on slide 11 of the PowerPoint that was uploaded tonight, the raw notes 10.1. And I'm finding where -1.0 crosses with 0.00 on the table. And that gives me a value of 0.1587. So that would be my area to the left that I shaded in orange here. So that would be the proportion of pregnancies lasting less than 250 days.
Okay, questions on this example, and then I guess we'll go on to number C, and then we'll bid this problem adieu. So any questions? And either you can raise your hand or you can, write text or whatever. I don't know what they call that chat. There's somebody. Josh, go ahead, please.
Hi, okay. So how did you get that from that table again? Because I was just pulling the table up as you were going through it.
So remember on your table, then you have z-scores along the edges. So
Right.
I found where -1.0 was right there, and then 0.00 right here, and then the 0.1587 was about there.
So, okay, so it was -1.0.
Yeah, because when I calculated the z-score, then I just got -1. So that would be -1.00.
Okay, so, okay, I see -1. Okay, I see it there now. Okay. I'm sorry.
And I want to commend Josh, but I want to commend everybody who asks questions because that's what we're here for, is to answer questions. And so that's excellent, and everybody should feel free to do that and do that. Anything else on this example? Okay, now Linda's going to go back and we're going to look at problem number C, I guess, on this. And Linda, I think it's probably okay. You'll have to redraw those things again, but I think it's a different question we're doing anyway.
Yeah, so this one is asking between 240 and 280 days. So I'll erase the whiteboard and then just resketch it.
Yep, I think so.
Okay. So I do still have my X space and Z space. That was terrible. But now I'm looking for between 240 and 280. So that's actually going to be this area in between these values. And remember, my mean was still 266, and my standard deviation was still 16. So I need to calculate the z-scores for both of these. Because to get the area in between, what I'm actually going to end up doing is kind of taking two different curves So I'll have my z-score for the 280, and I'll figure out that area to the left. And I'll find my z-score for 240 and figure out that area to the left and subtract them. So to calculate these two z-scores, I'm using the same equation from before. So x minus mu over sigma. So if I plug in 280, then I'm doing 280 minus 266 over 16. So that would give me a positive 14 divided by 16. So that is 0.875, which I'm going to round to be 0.88. Now that's not an area, that's a z-score. So when I find the area corresponding to that z-score in my table, so I'm going back to slide, I believe, 12. Then let's see. 0.8 crossing with 0.08 gives me 0.8106. So that would be the area to the left up here.
At the top, yes.
So then I'm going to do the same thing for 240. And when I throw that into my calculator, then I get negative 1.625, which I'm going to round to be negative 1.63. So now I'm going to slide 11 in the PowerPoint with my negative z-scores. And negative 1.6 crosses with 0.03. And that brings me to 0.0516. So then from here, all I'm doing is subtracting those two values. And I get 0.759.
Questions of Linda on this problem? Please. Oh, there we have something. Let's see. I'm going to read. Well, go ahead.
Because the table actually uses two decimal places to find the area under the curve, then you shouldn't round it to negative 1.7 or positive 1.7 or whatever you did. You would need to round it to two decimal places.
Now, I'm also going to tell you something. Once upon a time, Jim, and Josh, I see I'm going to finish my statement, but then I want to recognize you and hear your question. Once upon a time, Jim would have counted it wrong if you rounded that wrong. I don't think I would do that anymore if it was minus 1.6 or whatever. If the number was really quite close to that point, let's see, the difference was 0.7590. If you had something quite close to that, I would probably say, yeah, I think you were doing something right, and you know that's kind of okay. So certainly Linda is suggesting good protocol about rounding those things, but beyond a wholesome discipline, I will grade these things a bit gently. Okay, so Josh, go ahead.
I'm sorry, I must have missed. How did you get that 0.7590?
So I got the 0.7590 by doing the 0.8106 minus 0.0516.
Okay, that makes sense because you got your right end and your left end and your okay. Got it.
I'm finding the area in between them.
Yes. Nope, makes perfect sense now. Thank you.
Okay, other questions for Linda on this problem? Linda, I'm not seeing or hearing any. So what we're going to do is we're going to go back to slides.
Okay.
And we could do some other parts of that, but we're not going to because they're all, more, pregnancy kind of things. Now this one is a little bit, oops, let's see.
Yes, you would always subtract from right to left.
Probability is always bigger than zero. Bigger than or equal to 0. Okay. And that's how you know. All right,
yeah,
good.
If you end up with a negative probability, something went wrong.
Okay, now I'm going to do this one. And Linda, I actually think for some reason we were on this one last time. But you remember that I said there were two great problems. There were two great spaces. There's X space and Z space. And there are two great problems. One is given some numbers, find the probability. The other thing is, given probabilities, find some numbers. Now you see this problem, I'm going to read it for you, but this
we did do part A last time.
We did.
I think we were kind of jumping around.
Oh, okay. All right. So anyway, this problem is going to be another example where what we're going to be doing is we're going to be finding a number given the probabilities. And so I'm going to read this and then I'm going to go straight to B. The reading speed of 6th grade students is approximately normal. We're assuming it is exactly normal, with a mean of 125 words per minute and a standard deviation of 24. I'm sure Linda's writing those things down. Now, in part B, then, a school psychologist wants to determine reading rates for unusual students. That is both slow students and fast students. Now, we talk about unusual being 1 out of 20 or 5%. So that means she wants to figure out what is the middle 95% of all 6th grade students. And I think I said, and it certainly comes to my mind today, is when we're finding confidence intervals, that's what we're finding. We're finding the middle percentage. So this is an excellent transitional thing for that. So we want to know the cutoffs for unusual readers. That means we're finding the middle 95%. Linda, are you good to go then?
Yep.
Okay, take off.
So let me share a whiteboard. So once again, my mean was 125 and my standard deviation was 24. So if I'm finding the middle 95%, then that means I have 2.5% on either end. So I need to figure out what those Z values are. That way I can find the X value. So when I'm looking at my table, then the Z value for the left-hand side is going to correspond exactly to 0.025. Then for the right-hand side, then it's going to be 0.975. So I need to find the Z-scores that correspond to both of those. So I'm looking back in my PowerPoint real quick, and on slide 11, I'm looking for 0.025, and that looks like negative 2.81. Nope, that would be 0.0025.
That's in the body of the table, yes?
Yes. Okay. Skimming through the body of the table to try to find 0.025.
And the closest number to that?
Yes. Okay, so I found it at negative 1.96. So negative 1.96. Yes, Sydney?
So you're just checking the Z tables for these numbers?
Yes.
Okay, thank you.
So where does this number appear in the middle of the table? What's the cross section?
Okay, thank you.
And then if you actually look at slide 12, I believe, for the positive Z-scores, then since the normal distribution is symmetrical, then you should end up with positive 1.96. So using these, then I'm going to figure out what my X value is. And I'm just plugging these into my z-score formula. So I take that negative 1.96 and I'm multiplying it by 24. And then I'm adding 125. And my first value for x on the left-hand side, so the lower bound, would be 77.96. And for the right-hand bound, then that would be a positive 172.04.
Okay, so a couple of comments here then. So you see the cutoff for someone who is an unusual, and that's by our definition, slow reader is underneath that number that Linda found that was 77.96. And someone who is at 172.04 or better is an unusually fast reader. And I do want to tie this back a little bit to the empirical rule. And the empirical rule said that we would expect to have 95% within plus or minus 2 standard deviations. You can see that's a little bit of a round off, because what really happens, and Linda showed you this here, that it's really not minus 2 and plus 2. It is minus 1.96 and it is plus 1.96. Okay. Any questions of Linda on this problem? Okay, Linda, that was apparently a brilliant job. I thought it was pretty good, too, and apparently it made the students happy. Okay, so that is good. So there's 2 great problems, and we talked about those a bunch, and I think we're going to talk about something else. And I think we're going to turn our attention to the homework that's due, I don't know, Monday at midnight or something. Okay, so Linda, let's go back to the slides.
Okay.
Okay, and let's move to the next slide. I know what I'm looking for. Yeah, don't. All right, here's the thing. Now, what we're going to be talking about right now is we're going to be talking about determining, if you get a sample, does that sample come from a normal distribution or not? Okay, and that's pretty much the problem I gave you, and there's a bunch of things there. But in the midst of all those questions, I did ask you, hey, let's look at a picture. Let's look at box plots. Let's look at histograms. Let's calculate some skewness. Let's compare using the empirical rule. You see, we're trying to figure out, does this look like a normal distribution? And there's one other thing that is talked about in Michael Sullivan's book. I didn't ask you to do this on the homework, it is called, not homework, it's called low stakes assessment. But on low stakes assessments, I think I asked you the first 4, and then I asked you to, make some comments on that. But we will talk about this normal probability plot a little bit, time permitting, and I think we're doing just fine, so we'll probably be able to permit that. So everybody realize we're going to be doing this, and Linda, I'm going to be asking you to, go back, and we'll make sure we do all of this. We're going to do the top 4, and I can probably even remember those, but we'll see. Okay, so now we're going to look at a problem. I'm going to read the problem. While I'm reading the problem, Linda probably will be frantically typing numbers in. And Linda, I'm sorry, I really am pedaling as fast as I can. Okay, let's go back to this next slide though then, Linda, please. That's not the one. Wow, advance this a couple of times. There, this is the one I want. Okay, so I'm going to be reading this, and Linda's going to be entering that data into probably Excel. So I'm going to read this for a while. Okay, so this says, and by the way, we may come back and we may do what the directions are, but I'm going to just pretend this is the data I gave you. So a random sample of college students aged 18 through 24 was obtained, and the number of hours of television watched in a typical week was recorded. So you see, they randomly got the names of a bunch of college students, and they interrogated them, or maybe they observed them. Somehow, though, They said, well, what was the number of TV hours of television that you watched in a week? And you see these numbers are all over the place and everything else. But pretend for the moment this is what I gave you as the sample. Now, everybody realize there's a sample there, and so we're trying to figure out, gee, is it a normal distribution if I looked at not the sample, but if I looked at the entire population, all 18 through 24-year-olds, do they behave in the same way? Okay, is this a normal distribution? Okay, so when Linda is finished entering those things in, we're going to do a few of the things that I ask you to do. Okay, so Linda, once you've got that entered in, go ahead and change the channel and I'll continue talking and you'll continue to do things.
Okay.
But everybody understand, I'm kind of mirroring the problem I asked you to do with this. And we'll get to the questions being asked here in a bit. Now, hey, everybody realize that Linda intelligently put those in a column. Linda, tell us why you did that.
Well, they're all from the same data set, so there's no reason to separate them.
There's no reason, and in fact, there's a lesson here, and I deliberately picked this problem for this reason. Data always doesn't come the way you want it to come. Sometimes you have to reformat it. So Linda did reformat that so she can pull down things and use the formulas and things like that. So that's good. Linda, why don't you make a box plot of this data?
Okay. So I'm starting just by highlighting all of my data, and then I'll go under Insert. I'm looking for a box plot, so let's see. A statistics chart would be good. And there we go.
Okay. And Linda, now we're going to do a poll. And by the way, don't worry about being right or wrong. Just give it a go. If you're wrong, you'll learn something from it. Is this symmetric or not? Symmetric or not? And weigh in too, because I want you to think about, is this a symmetric set of data or not? And by the way, it's a sample, so it might not be exactly symmetric, but does it make you think, yeah, it's symmetric? You see, if you saw this as way asymmetric, that would make you question it. Okay, some people aren't playing, and that's, of course, all right. We don't make people play. I know she's going to be right, so I'm going to ask Linda. Linda, what was your opinion on this? And tell us how you arrived.
I would say yes. It is not exactly symmetric, but it is roughly even on both sides. So I'd argue that since it is just a sample of the data, then yeah, this is probably symmetric.
Okay. Now, if you looked at what I gave you for a low stakes assessment, I gave you a lot more data points, but this was fair, and that's what we did. Okay. Questions about that? By the way, if I asked you to do something like this on the midterm exam, I would expect you to fax it, or not fax it, what is it called? PDF upload that to Blackboard. Nowhere else will it be accepted. So you need to do that. And again, I'm not trying to be mean with that. I'm just saying that's part of the wholesome discipline that we're trying to do. Okay, and Linda, I'm not seeing any questions, so now I'm going to ask you to do something else.
Okay.
Hey, draw a histogram of this and just see what happens with that.
So just like before, I am highlighting my data, and then I'm going under Insert, and remember, a histogram is a bar graph. So there we go.
All right, and okay, and what the hell, let's just do, well, it's the same data. In fact, we're not going to do another poll. I mean, if time were infinite, I'd do more polls and stuff like that. Linda, talk about, does that look pretty symmetric to you? Or at least, is it making you say, hell no, this isn't symmetric?
I'd argue you could say either way. I mean, you do see a lot of symmetry down the middle if you call this the middle, but there is a little bit of skewness happening, so you could say that it's skewed to the right. But
Okay.
based on our box plot, then I'd say it's still pretty symmetric.
Okay, so it's pretty symmetric. And again, you notice that there was more detail that came out on this one, or at least a different kind of detail. Again, that's what I asked you to do. I asked you to make a histogram and then, you know, talk about it. Now, again, realize that we're talking about a sample. And let's see. There was a basketball player from China who played in the NBA once upon a time named Yao Ming, and I remember that I think he was 7 feet 6 inches tall. So he was really, really a tall fellow, much higher than that. You see, it's really possible, even if you're grabbing a random sample, you might reach into the world and grab a bunch of Yao Ming's relatives, and you would have a distorted view. But generally, you say, no, a sample is going to be a pretty representative thing. And so this kind of says, yeah, so far this looks like normal things. Now, Linda, let's see, I'm trying to think of the other thing. Okay, now, Linda, what we're going to do is we're going to test the empirical rule on this. And Linda, I'd like for you somewhere in that Excel space maybe to list what the empirical rule says. And Linda, it's kind of a table. And here's what I'm really trying to say, Linda. Maybe you could put words there. Within one standard deviation of the mean we have, and it's going to be 68%. Within one SD is fine, and it's 68%. Within 2 SDs, and by the way, that's of the mean, and maybe Linda will go back, and I know I didn't say that, but maybe go back and put that in there too. It is 95%. And within 3 standard deviations, it is 99.75. So so Linda, maybe she'll put within, you know, that distance, within so many standard deviations, maybe of the mean. Maybe she'll add some other numbers there or something. I don't know. Okay. Now that's what we have with the empirical rule. But how about our data? Now, this is going to be a bit of a calculation, though. And so, you see, I am asking you to do, I mean, you might say, oh, that homework wasn't bad at all because all I had to do was draw some charts. Well, now there's a little more work that's going to be involved because that was, and Linda maybe will put a title on that first column that she did there, not first column, the second column, I'm sorry. And put, no, I'm not communicating well. And that little table you were just building, way down there. Okay, on top of 68%, put EP, empirical rule. Or she's spelling it so you know what it says. That's good. So that's the empirical rule thing. But the next one is our data. And this is the question I'm using. And our data is this thing up here. Okay. Now, I'm talking to everybody. I'm talking to Linda too. But you see, there's a lot we have to do here because what we have to do is we have to figure out, since this is standard deviations of the mean, we have to go back and figure out what is the mean of our data and what is the standard deviation of our data. And we have to determine what percentage of the values are in various places. So your first step, and Linda's first step, is going to be finding the mean and the standard deviation of this. And Linda, of course, you're going to be using these, what do I call it?
Formulas?
Samples. Yeah, but it's the sample. It's the population. Yeah. Okay, so Linda's talking. I'm going to shut up. Go ahead, Linda.
Okay, so what I just did was use the average formula to compute the mean. And then I'm doing the sample standard deviation. So that is STDEV dot S because it is a sample. And then I'm highlighting my data and closing my parenthesis. So that is my standard deviation. So I believe it would be easiest for me to sort this data.
You bet.
So I'm going under sort and filter, and I'm just doing smallest to largest.
And Linda, I'm going to make a suggestion here, and
Okay.
and it's just because I've drawn these pictures before and I have an idea of maybe a cute way to draw this. Okay, so what I'm going to ask you to do is, in that thing that you have, column C, insert several new columns just so you can do some coloring here.
Okay.
And I know it's not clear what I'm thinking about right now, but I have an idea. Okay, and that's good. I think that's more than enough. Okay, now what we're going to do is Linda is going to say, and she's going to mark off here, and she's going, actually she'll probably go down and compute, what is the mean plus 1 standard deviation, and what is the mean minus 1 standard deviation. So she's going to go down and she's going to do some calculations down there.
Okay. Hold on a second. So plus 1 and minus 1.
Okay, but that is, and everybody understands that, that's the mean plus 1 and the mean minus 1 standard deviation. Okay.
So then I'm doing equals, I'm taking the mean plus 1 standard deviation, and then the mean minus 1 standard deviation.
Okay. Now what Linda's going to do then is she's going to go up and she's going to find where that cuts off in the data. And Linda, I'll let you choose what color you're going to do. But in that thing that now is column B, you can color that thing whatever color you want, some pastel color.
Okay. So I'm going from about 10.4-ish to about 31.4. So that would take me from here to, let's see, 31 point, that ends just a little bit before 30, hold on. Yeah, so it would include the 30.5. So from 16 to the 30.5, then I will highlight that. Let's see, we'll go with pink.
And Linda, how many data points are in the pink?
Well, we go from 7 to 21, so 21 minus 7 is 14, plus 1 gets me 15.
Okay, so what we're going to put is 15 over, and I'm not sure how many data points were there, Linda?
25.
Okay.
So our data is 15 over 25. So we get about 60% of our data within 1 standard deviation of the mean.
Okay, so that is good. Now Linda is going to go and she's going to do a similar thing. I just will let her talk, but we'll find out what happens within 2 standard deviations of the mean. Go ahead, Linda, please.
Okay, so I'm doing roughly the same thing, where I'm taking the mean and now I'm adding
And
2
Sydney, I'm going to call on
times
you in
my
just a minute.
standard
I'm going to let
deviation.
Linda talk.
I just had a quick question. How did you, what did you put the number of like cells over what number to get the 60%?
So I just took the 15, the number of cells that fell within that range, divided by 25 because there were 25 data points.
Okay, thank you.
Yep. So then I'm doing the mean minus 2 times the standard deviation. So from negative 0.13 to about 42. So I believe that's actually all of my data. I don't know what happened there. Okay, so because that is all 25 data points, then this would just be 25 divided by 25. And then I don't even think I need to do within 3 standard deviations of the mean, because that would just take me further negative and past even more of my data.
But
So
the
that would
answer is
still
1.
be 100%.
Okay. Now, you might say, wow, something went wrong. Well, not really, because 95 isn't too different from 100%. Okay. And yeah, and Linda, I actually had not done this problem, so I didn't know exactly how that would pan out. But that's what I'm asking you all to do, but it's with a different data set. So you got to do these calculations, and I don't think it will end up this way necessarily, okay? But I'm asking you to compare it to the empirical rule. Now, I got to tell you, when I look at the symmetries and I look at the, this stuff, I don't really, I don't walk away thinking that this is, let's see, I would probably conclude after looking at these things that, yeah, this could certainly have come from a normal distribution. Now, Linda, you and I are now going to investigate skewness. And I'm going to ask you to somewhere on that Excel spreadsheet type Pearson, just the word Pearson. And this is not the publisher who I, have ranted and raved about. This is a different Pearson. He is Carl Pearson, a great statistician. And he said that one way to evaluate the skewness was to take the ratio of, and she may want to even write this down. Now that is in my lecture notes or in my videos, but just write skewness is equal to, and I think there's a factor of 3 for no real good reason, but it is 3 parentheses mean minus median. And put those in parentheses, mean minus median, and then we divide that by the standard deviation.
Okay.
And the reason, one reason that you would do this is, you see, if you take the standard deviation, the mean minus the median, skewness is a dimensionless quantity. It doesn't come up with anything. This was like hours of watching TV. You just get a raw number. So Linda's going to calculate using this formula what it says the skewness is. So now Linda has to figure out where the median is, and she's going to go up and she's going to use it. This is good review for the final, I think, too. So she's going to go up and she's going to use the Tukey definition of the median to find it.
So remember that the median, to find it, then we're doing n plus 1 divided by 2. So because I have 25 data points, then 25 plus 1 is 26, divided by 2 gives me 13. So I'm counting down to the 13th data point, and that is my median. So 20.4 is my median of this data. So then to calculate my skewness, then I'm doing equals 3 times, in parentheses, I'm taking my mean minus the median. I'm closing my parentheses, and then dividing by the standard deviation.
Okay, and we get?
So about 0.1437-ish.
Now, if this were completely, and this was in a video that I asked you to watch, if this was perfectly symmetric, this number would be 0, because the mean and median would coincide. Now, that's not a very big number, and in fact, that is a positive number, and Linda will go over and we'll see that there is a small positive skewness in the histogram, and Linda was talking about that before.
Yeah, so the positive skewness means it is skewed to the right. So if positive, skewed to right, and then if it was negative, then it would be skewed to the left.
And it's the direction of where's the tail. It's all about the tail, okay? All right, I'm going to pause here just a second. Questions of Linda And we're going to do one other thing, Linda, in a bit. But questions? Okay, excellent. Now, Linda, I think the version of Excel that I was lecturing from has this. There's a formula called skew. Now, and so I'm going to ask you to calculate the skew. Not, by the way, students, I ask you to do it both ways because I don't know, it's nice talking about Pearson, but everybody does more research on statistics. They change things and everything else. So Linda is going to calculate using Excel, a power function, skewness.
Okay, so I search for skew and look at what we got. Now, just to double check, then this is skewness based around a population. So I believe we would need everything from the population to use that one. So we're just using the skew formula. But it's always nice to double check. So then I am highlighting the data and hitting OK. So
Now,
here we actually get a negative skewness.
Okay, now you see what happens there is that surprises me. Anyway, it's a different formula is a point, and it is still very close to 0. So I guess, Linda, I'm going to say it's a different formula.
Yeah.
And so, but is it pretty much? And in fact, in this case, I think I like Pearson's better than that, but it's damn close to 0 is the point that I'm saying. Okay. And so if it's damn close to 0, that says, oh, this makes me think this is probably a normal distribution. Okay, question, still close to 0. Okay, so symmetric. All right, and that's a lot of what I ask you. In fact, that might be everything that I ask you to do on that little exercise. So questions of Linda before we move on. Okay, Linda, let's move on.
Okay.
And Linda, what we're going to do is we're going to go back and we're going to look at some of those slides before the problem. Then we're going to actually do what the problem is asking you to do.
Okay.
Everybody, I am watching the watching the time as well, so we're doing fine. Okay. Now, was there a slide right in front of this one or no?
Just another problem.
No. Okay. Fine. Go ahead.
Yeah.
Okay. So let's go to that one then. All right. I'm reading a little bit to you, but a normal probability plot is a graph that plots the observed data versus normal scores. A normal score is the expected z-score of the data value, assuming the distribution of the random variable is normal. The expected z-score of an observed value depends on the number of observations in the set. Now, here is what Linda is going to do in a minute. She is going to look at our data, and she is going to do for each of those, first of all, she's going to sort the data in ascending order. Then she is going to calculate a column using the formula f sub I, that is the frequency of the ith observation. And Linda, once you sort them, what I'm going to ask you to do is also have a column that's the index. So in fact, maybe that's the very first thing I'm going to ask you to do. Go up, because you're sorting them, you want to have a column that says, oh, that's the first data point, that's the second data point, and so on and so forth. Okay, that's what I is. And then she's going to say the frequency of the ith measurement is I minus that over n plus 0.25. And I is the index, that's the position of the data value. I think, Linda, you understand what I was saying with that. And n is the number of observations. Okay, and then what he says here is, damn, you have to find the z-score for all of those 25 things from table 5. We're not going to do that. We're going to use a power Excel function tonight, and it's going to be, and Linda and I will talk about what that is, and I will, tell you the one I want you to use. And then what you're going to do is you're going to plot these on a scatter plot. And so you're going to plot the z-scores as the x, and the y's are going to be observed values, and you're going to see, is it a line or not? In fact, Linda, let's see what the next slide says.
Okay.
Yeah, if it is approximately linear, and we'll talk, we know how to do that. If it is approximately linear, that means that it is a, we think it's normal by this test. And we have a way of determining that. So we're going to do this, and we're using some Excel power functions, but this is a really good review of some of the stuff that we talked about, and we're in really good shape. I do know what time it is, so people don't get worried about that. Okay, so Linda, let's go back to our data.
Okay.
In Excel. Okay, and what Linda's going to do is, and you may want to put some additional I don't know, spaces there, that's up to you. If you want to put a space to the other side, I don't know, you want an index thing anyway. Index is what we're going to call it. In fact, you want to maybe have these labeled. I don't know what you want to do. I'm going to shut up and let you do it.
I'm working on it. So I'm actually going to add a row. That way I can title this one as index, and I'll label this as just my data. So for the index, we're just labeling these as 1 through 25. So
good.
I'm taking each of these and just adding 1, and then I can drag that down.
And then she's going to sort the data.
So the data's already sorted.
Oh, you already did that?
Yep.
Okay, cool. Wow.
Yeah, when we had to find the median.
Oh, okay, good. That's cool. Okay. If it wasn't sorted, you'd have to do that. Okay. All right. Now, Linda, you're going to have this column that is F sub I thing. And
Okay.
that's the formula.
So F sub I equals, so what I'm doing is taking the index, and then I am subtracting 0.375. I'm closing my parenthesis, and I'm dividing this by, since n is 25, then this is 25 plus 0.25. And that 0.25 is just part of the formula, not because this is 25. There we go. And then I can drag this all the way down.
And Linda was very careful with her parentheses, as you should be as well. Okay, now notice that got almost, you see, if you start at the top, it's a number close to 0, and then it goes all the way up to, I don't know, 97. That's almost to 1%. But now what we're going to do is we're going to do, this next column is going to be, I don't know, it's like a z-score, so put z-score.
Okay.
And now what's going to happen is, and I'm going to let Linda not look all these things up. We're going to use a power Excel function. And so this is going to be equal to inverse normal dot S or something for sample. Linda will look that up. Inverse.
Yeah.
It's INV. Yeah, in fact, she'll do it that way, I guess, which is fine.
So let's see. I'm just going to search for z-score. No, didn't like that. How about normal? Let's see.
And if you want to, you can go to all and look for I. Okay, the normal inverse dot S, that will do. You go up, you see that one?
Yes, I believe that's it.
Now, I think this is the, let's see. Now, by the way, this is one thing that you might say, why do they have more formulas for this? Some people are used to using old versions of Excel, and they throw those in there. The new version is that one, probably, Linda. Okay?
Yeah, because you can see that the function that you're applying, then you're using probability as the input.
Okay, so go ahead and do this then, please.
Okay, so this is for each one individually, and then I'll have to drag down the formula. Okay, so I'm doing my z-scores.
Now what we're going to do is Well, we could do, in fact, let's do this. Let's do a scatter plot of this, and we're looking at the z-score as the x, and we're looking at the data values as the y.
Okay. So let's see. For a scatter plot, then you said to use the z-score as the x and the data as the y?
I don't so much care, but I mean, it doesn't matter. Go ahead.
Okay. So I'll just highlight these and see what happens. So I'm holding down, let's see. I think if I hold down Control, then I can highlight both of these. There we go. Beautiful.
Okay. Now, you have to say, well, gee, I don't know if that's a line or not. You know, I mean, it looks kind of like it. It certainly doesn't, I mean, it's not horrible. It's more or less like a line. But we have a way of measuring that, don't we? And we can compute the Pearson correlation coefficient of this. Remember, that was R, and that's going to be on the midterm as well. So the correlation coefficient of those datas are, and Linda, go ahead.
Okay. So I'm doing that same CORREL function, and it doesn't matter which one I put as X and which one I put as Y. So I'm highlighting my data first, comma, and then I'll highlight my z-scores. And then closing my parenthesis, and that is a pretty dang good line.
So Linda, what would you conclude? Is that a pretty good line? I guess.
Oh yeah.
Okay, so you see that's there. But let's just review, pretend it wasn't quite as good. Linda, I put the table for the correlation coefficients there. And so we're going to check, is that good enough?
Well, for 25 data points, then let's see. Let me bring up the PowerPoint again.
It's there somewhere.
Yeah, I'll just bring it up on mine. So for 25 data points, it needs to be better than 0.396, which we see right here. And 0.99 is definitely greater than that.
So all of these things together, Linda, do we conclude that that is probably a normal distribution?
I'm going to say that's probably about as normal as it gets.
Okay, very good. Now let's go back then to the problem that started all this business. And we did a whole bunch of things with that. And we might not have done it all. Let's see. It had something to do with teenagers or college students, I think. Here it is in TV. Okay. Draw a normal probability plot to determine this could have come from a normal distribution. Linda already did that. That's the line that she drew. Okay. Determine the mean and standard deviation of the sample data. Linda already did that as well. Okay. Number C. Let's see. Using those, draw a graph of the normal model for this distribution. It'd be a bell-shaped curve. It'd have those means and standard deviations. I'm not going to worry so much about that. But what we want to do in part D is use that model. You see, all we need to know is the mean and standard deviation. Find the probability that a student watches between 20 and 35 hours. Okay, so Linda, you've got, I think, a lot of stuff there. It's between 20 and 35 hours. And wow, I don't know if you need to go and look on your Excel spreadsheet to write down some numbers or if you're doing that, but this is, let's see, Linda, I'll let you pick. Do you want to do D or E first?
Probably E.
All right, she wants to do E. So let's do E then. And so we're going to do that like with X space and so on and so forth. And I am watching the time, Linda, so you have 5 minutes.
Okay. So let me share my screen again. So we are finding the proportion that is greater than 40 hours per week. So I need to figure out what the z-score would be for 40. So let's see. Actually, I think we need to find the equation of the line, right?
No, you know a normal distribution that the mean standard deviation. So you're doing
Okay, so you're just going through the normal motions. Okay.
Yes. Yeah.
So for 40, then I'm doing my z-score, and that would be equals, so I'm taking 40 minus the mean, which was 20.904, and then I'm dividing that by my standard deviation. So I get a z-score of 1.81. So then I can look in my table to figure out what corresponds to, actually when I round that I get 1.82. So I'm going back to my PowerPoint and looking for the value that corresponds to 1.82, which would be right here. So that is 0.9656. So 0.9656. But remember, this is to the left of the curve, and our problem in part E asked us for more than 40 hours. So that would be to the right of this line that I would be drawing in my graph. So really what I need to do is equals 1 minus that number that I stole from the table. So about 3.4%.
Okay, excellent. Now, Linda, let's go back to the slides. I am watching the time, folks. I know some of you are leaving, and that's your choice, but I am watching the time. I'm going to dismiss you pretty much on time. I take pride in doing that. Okay, so we're going back to the thing. Dimpy, the very best thing to do is to come to GSG or come to my office hours. I have office hours right after this course. By the way, some students send me emails and write me texts when I'm trying to lecture to them. And I think it would be good if they actually listened to what I was saying instead of sending me emails. So Dimpy, if at all possible, first of all, I'm going to ask you to stay after this so you don't have to wait 15 minutes. So if possible, stay after this and I will stay late and I will talk to you face to face. And I don't know if you left after you sent that comment or not. But anyway, that's the best thing. So I will stay here and try to answer your questions there. Okay, so Linda, go back to way earlier slides, all the way back to the beginning of the kind of outline of what we were going to do.
This one?
No, keep going backwards.
Okay.
I'm sorry, but there. Okay. Now you see we're doing just fine. Now my lecturing is a little bit ahead of this. We now tested to see if a sample comes from a normal distribution. We did that today. And I was giving you lectures on sample and also on confidence intervals. And again, I think time was well spent tonight, but we're going to do confidence intervals, next time. So anybody who wants to talk with me and things like that, I would encourage you to hang around instead of just sending me emails, because I get busy doing other things, and neither Linda nor I do sit in front of our computer watching for emails. I try to answer emails during my morning office hours and my evening office hours, and sometimes in between. And it's not that I don't love you, but I'm juggling about 9,000 emails, literally, okay? And so that's a thing. So what you can do is, those are the videos that I Yes, I do send a lot of videos. Why don't you stay and talk to me, and we'll make sure that that's all good. I mean, I do want to answer your question, but answering the test, so just hang around. And anybody else who wants to talk to me, who can do that, I'm going to stay here for a while till people are gone, and I can answer your text if you want to do that instead of talk. But I'll stay here for a while till we get that exhausted. Okay. Linda, thank you. Oh, time is precious. Each day must count. Do the math, it'll make you strong. And we finished exactly on time. Is this class well planned or what? Okay. And Debbie, if you want to ask your questions again, that will be